In this video, we're going to go over a simple Solana program that prints hello world to the program logs. Every Solana program has an entry point that takes in some function that requires a program ID, the accounts required by the instruction, and some instruction data, which is just a slice of bytes. And then the body of the function is the business logic for our program. And in this case, we're just printing hello world to the program logs using the MSG macro. Once you've written your program, to build the program, you simply run cargo build SBF. So when we run this cargo build SBF command, what we get is this deploy folder with a key pair that's generated for our program, where the public key here is used as the program ID for the program we're about to deploy. And the compiled program is in this .so file, and the contents of this file is what actually gets stored on chain on the program account. To deploy Solana program, we use the Solana Program deploy command, followed by the file path to our .so file, which is under target deploy our program name.so. Once the program is deployed, it'll log the program ID, which is the public key associated with this key pair here, and the signature for the transaction that deployed the program. If you ever want to view the address here again, simply run Solana address, passing in the path to the key pair. So here we see the address matches our program ID, which is what's in this file path, which is this file here. Now, once we have our program deployed, we can then invoke the program from the client. So here is a basic example of how we would invoke our program that we just deployed from the client. We're using the following dependencies, where we have our program ID here, and we're using our local test validator. Within the body of our main function, we first create a connection to our local test validator, generate a new key pair, calling it the pair, request an airdrop to the payer address for 1 sol to fund it, wait for the confirmation, and then we will go ahead and build the instruction to invoke our program. So the program ID for our program is listed as the program ID constant above. We then create an instruction to invoke our program using instruction new with bytes, passing in our program. Since our program doesn't require any accounts or data, we just pass in an empty slice and an empty vector here. So now we have an instruction invoking our program. We can then fetch a recent block hash to act as a timestamp for the transaction, then create a new transaction using new signed with pair, passing in the instruction we just created here, passing in the payer public key as the payer for the transaction, and then passing in the key pair to sign the transaction and the block hash to timestamp the transaction. Once we have our signed transaction, we go ahead and send that transaction using send and confirm transaction, which will return the transaction signature, which we can log to view on Solana Explorer. We can go ahead and run the script using cargo run, where we see the following output. So here we have our transaction on Solana Explorer. If we scroll all the way to the bottom, we can see that our program has a single instruction that invoked our program at this address here with the following program ID. And if we inspect the program logs, we can see that the program has logged hello world. So that's the basics of a Solana program. We have some entry point that begins the execution of the program. The program takes in the program ID, some accounts, and some instruction data. When we need to invoke the program on the client side, what we do is we create an instruction, specify the program ID, some data, and some accounts that's required by the specific instruction we're invoking on the program, which corresponds to what the program expects here. Next, let's take a closer look at this entry point macro. The simplest way to think about Rust macros is that it's a function that takes code as input and produces more code as output. So to the left, we have our entry point macro that takes in this process instruction function as an input. The output of this macro, we can see to the right-hand side, which is the expanded version of this entry point here. What this generates for us is the following code here. What we're going to take a look at is simply this first function here. It's just a program that takes in some bytes, deserializes the bytes into the program ID, accounts, and instruction data. Within the body of the function that we pass into the entry point, it'll do something with these inputs and either return OK if the instruction processes successfully or some error if something goes wrong.